Welcome. So in this video, we're going to talk about how we would utilize the cloud to crack passwords online. So before we get started with this slideshow, I'm just going to say that I will hide my face while presenting every single slide. And in this slide, I will talk about exactly what is done, how you do it, and different kind of things like that. I will not get into the technical bits totally because it'd be a very long video, but I will create a link or few links in the description below where you can go ahead and continue your journey if you want to do cloud computing, cracking in the cloud. So without further ado, let's just get started with the slideshow right away. Now, the different kind of hashes that I do mention in this slide is the mention of NTML is present on this particular slide right here, just for you to see that there is a difference on the amount of hashes that can be cracked per second if you use like NTML, WPA, or NTML version 2. So the one we use in the slideshow is WPA. So I decided that I want to talk about how fast we can crack the Wi-Fi passwords, more specifically the WPA type of passwords in the cloud. I know that there are probably different kind of versions to this because this is just one version taken from the Amazon Web Services at some point in time where they had this kind of configuration you could hire in their cloud services. If you're going to use something like, let's say, Asia, or you're going to use DigitalOcean or another cloud service, maybe you're going to create your own. That's going to be a totally different calculation. So this is just based off what you can go and hire, what is public available. So I think this is going to be more useful in terms of what is actually possible for the majority of people that get their hands on a big list of passwords. So this slideshow will only focus on the WPA, e.g. the password for Wi-Fi. So let's talk about what a password is just briefly. We all know that, you can see the picture of the log, that the password is something that holds the access to something. It protects against unauthorized access. It is what you call confidentiality, and the typical password length is probably in between 8 to 12 characters. And that is what you probably think, this is a password, this is what it is, this is what it do, and so on. And I totally agree with that, but the question would be, is 8 to 12 characters enough? Now, through this slideshow, we're going to talk about whether it is or not is, and I'm going to present to you different kind of calculations, and I'm pretty sure that you will be a bit surprised from what I say in the next couple of slides. But let's continue. So I just want to talk about briefly that you're going to use the program called Hashcat in this example. So Hashcat is the program used, and it is the benchmark of Hashcat that is also used to do the calculations. So Hashcat can be directly asked to create a benchmark, and then it will show from a particular speed of the computer and so on how many hashes it can crack, and basically that is what this slideshow is calculated from. So we're going to use Hashcat. It involves hiring several instances of computer power on the Amazon Web Services, the cloud service of course. It is very heavily based upon the GPU power, so we need some sort of GPU. And this is where you're gonna say, but hey, so the bigger the GPU, the faster the cracking, and that is exactly what I'm saying. So we're gonna use Hashcat throughout the slideshow. Again, I want to say this is very specific, just for one particular type of program. If you choose another program, well, then you would of course get different results. So just a disclaimer, bear in mind, this is very based upon Amazon Web Services and Hashcat. I think also just to mention that because Hashcat is so widely spread and people use it and people know it, well then it is a common program to use, and it will create a more realistic case on how fast it is to crack a password using these two services. The cracking approach can be done different kind of ways. I just want to talk about what we basically going to talk about in this slideshow is, Wordlist and brute force, but not targeted but precompiled Wordlist. But there is also a more, diverse, you could probably say, approach called a hybrid approach. And the hybrid approach would consist of doing several things like wordlist and brute force. Because if you do a wordlist, then you can say, but would it be a randomized wordlist like RockYou, or would it be like a precompiled wordlist with knowledge about password composition and length and so on? That would greatly differ the speed, because we could get lucky. And I'm gonna get into this kind of part of what do I mean with getting lucky in another slide, the slideshow. But these kind of approaches are the three, I would say, most common one that people use. Most people probably just do a brute force wordlist attack, which is just any pre-made wordlist that, probably RockYou, and then, just fire it off and see if you're lucky. And that's also perfectly fine to do. I would say the better way is to do the targeted, advanced mixing, where you do have some knowledge about the password lengths and rules, and then you pre-compile a word list. But this is again just something that would create a new category. You can call it hybrid word list attack. So you can mix them in a way you want. The best way of thinking about the cracking approach is it's all about the reconnaissance. So the more reconnaissance you can do, the more knowledge you can get about the company and the password composition they have, well then the greater result you will get with this kind of approach. So let's change the slide. And I want to say that Amazon Web Services is just one possibility, and they do offer these cloud instances called different kind of things. And in the images below, you can see that you just, from this menu, which is picked in, I think, 2022, where I found this image, just a random image that I got. You can pick the Ubuntu, which is this type of computer operating system, also used to calculate the cracking speed. And I want to say, depending on different kind of OSs, Windows, Linux, this different kind of distributions of Linux, even the Mac OS could probably yield different kind of results from the amount of cracking speed you can get. But I wouldn't necessarily say it would be a great difference, but I feel that Windows probably should be a bit slower. I don't know. Depending on how the operating system handled the load and stuff like that. I literally do not know these kind of things, but it is probably not that important. And when you're going to choose the instance type, well, that is where it's going to cost you some money, and there is some money, overview. I'm also going to show another slide in this video, the amount of money used and spent for the cracking purposes. So you can also go ahead and choose the free tier, and if you do that, you will of course get the very minimum of power. I think it's 1 CPU, and I don't know how many gigabytes of RAM it is, but probably 1 or 2, something like that. And even with that, you could probably utilize more free tier servers on different accounts and combine them together in a certain way, and could probably yield a pretty good result, even if you went all in. I haven't really thought too much about it, but how far you can get with free tier could be a funny, interesting project to do sometime. So the rough estimate of prices and the different kind of servers you can pick. Let's just go one back. I'm talking about the instance type right here. So there are different kind of instance types, and depending on which you choose, you will get the rough estimate of prices. For the one called GDDN X large, it's going to be like $0.5 per hour. And if you go all the way up to like the PD4 X XL24 large, well, then it's going to be $32, almost $33 per hour. And if you calculate that to a monthly, payment, it's $24,000 per month. And it's going to be a lot of, money all of a sudden. So you're going to see this is not free. But this is the amount of money it takes if you're gonna use Amazon Web Services. You're gonna hire them and use their computing power. So the mere setup itself might take, you know, a few days, and then you're gonna think, well, will I then pay $32.77 per hour if I don't use the computing power? Well, I can't say 100% for sure whether the money is going to be, you know, deducted from your bank account, but the thing is that Amazon Web Services is charging you for the compute power. So if it's not doing anything, well, it's probably going to be less. But then again, I wouldn't know if they change their plan. This is just the actual estimate of whenever it's running. So the baseline of this paper is based upon a 8-character password length. And the composition would be small letters, large letters, numbers, and a few select special characters. And you think, well, there are more than 5 special characters. Well, they are, but just for the sake of this video, I chose that composition just to show you with a very simple approach how many different kind of passwords we're talking about. We're talking about 360 billion passwords, and the number itself is just big. Just imagine what happened if you said like 9 characters or 12 characters, and just imagine if you actually extended the special character range with like 10 different kinds of special characters. The total unique of password, the total unique amount of password will be just exponentially bigger, like large, extremely big. And this is just for us to understand that we are still in the billion area, but we're in the 360,000 billion area. So remember that you take 1,000 millions to get to a billion, right? So it's going to be a lot of passwords. Imagine the size of the hard disk you need to save this file. You know, I just can't imagine how many gigabytes or terabytes or even more, whatever measurement we need to talk about in order to understand this kind of size, how much it would take. But think about it this way: RockYou is 14 million passwords. It's gonna be the first 8 characters, you know, and whenever you take it one step up, and we almost have like 8 more characters. We have 7 more characters after that, so it's going to be a huge amount of passwords. So probably very and highly impractical, because the implication of saving that larger file also implies you need to have a very, very big amount of RAM that can take a very large amount of data time. Else it would take just too much time, you know, reading from the file, you know, and pointing the file descriptor to read a particular line. And that would actually increase the cracking time. So we would require a big amount of RAM, which is also why we're going to talk about which kind of machines can be chosen. So if you're going to take a look at different kind of, you know, instances you can pick, and I know we haven't checked out different kind of instances just live, but these are some of the names. You can go ahead and check them out. They are on Amazon. Just, you know, I just briefly checked just before, and there's a list. You can go ahead and check them out. But I mentioned 3 of them in this slideshow, and in this particular slide here, I'm gonna talk from the brute force perspective. So we are brute forcing directly. You know, we have no password, we have no word list. This is just generating the passwords, you know, from brute force perspective. And the rough estimate would be that, you know, we get with the GD4DN large, we're gonna get a converted, you know, hash per seconds, 364,600 hashes per second. Now that is of course many hashes per second. I understand that. Even if you go down to the P316X large, you get 3.6 million hashes per second, and that is extremely, you know, it's many passwords. I understand the amount would seem like greatly hard to understand how we would generate so many passwords. But think about this way: it would take around 31 years, 106 days, 14 hours, 6 minutes, 46 seconds with G4DNX large to crack the 8-character password, and that would be impractical and not usable. And the two instances, the 16 and the 12 G5P3, are very similar because of the speed and because there is a diminishing return on the actual amount of speed there is to this kind of cracking thing. So converting the amount of hashes would take 3 years on both of them to crack the 8-character password. It's still very impractical and unpayable. You cannot do that on Amazon Web Services. I'm pretty sure if you did that, on 3-year base, someone would probably, notice that. And I would be highly skeptical if you could even make this run for a month without anyone noticing, like, what is going on right there? Why is this guy... I don't know if you're going to do that, or they're just going to look at it like, well, this is money, I don't know. But this is a highly effective way of doing brute force attacks. And I would say if we knew something, and this is just theorizing right now, if we knew something about the actual password, let's say we knew the actual composition, so we didn't have to like brute force directly. We could probably say like we knew that the password was always the first letter was capitalized and the last 4 were always digits and still 8 characters. Then we could create a specialized word list attack, which is going to be different from brute forcing. So we're going to use the word list approach, and the cracking speed would be the same. Sorry, not the cracking speed, but the character length and the composition would be the same, of course. And the cracking speed could be shown in this kind of way right here, and I decided to show like in a percentage wise 25, 50, 75, 100%. So assuming that you would do and be lucky that the password you were going to crack would consist within the first 25%, well, then it could be 7 years. All right, so that's going to be a lot of time with the G4DNX large. You could even take it down to under a year with the X large or the 16X large, which has identical performance in this particular case. It could be 288 days, and still a lot of time. But think about this way, and this is of course the worst case scenario. If, for example, you knew something about the password composition, let's say the amount of characters, or which one was used, or which basic characters was are not used, any particular patterns, in the organization, that could greatly reduce the time to days, just because you could create a very specialized word list. And with that approach, you could, increase the amount of hashes, increase the amount of possibility that you would, guess the right password, which is what cracking is all about. So I would say this is of course just the worst case scenario. That we have word list, you don't really know what's going on, but this word list is actually, and I want to say this example here is based upon a full word list with every single password within the 8-character exactly range. So if it's 7 or 9 characters, it's not there, and just think about it this way: if users are asked to create a password within a range, then you would need to do different kind of word list, or even combine all of them. And that is why this is highly impractical to approach these kind of cracking endeavors, because it's going to be very expensive and it's going to be taking a lot of time. Even so, if the password was in the first 1% of that password list, or the word list, that consists of every single combination of the 8-character password of the rules I specified just up in the description, would take like 114 days on the slowest one. And on the fastest ones, now we're beginning to talk about an amount of speed that is acceptable, 11 days. And that is actually pretty good. If you own these computers, you could probably let them leave for even 57 days, but still think about it this way. This is an overview of 5% of the word list. You can randomize it. You can take 5% random. You can just, say, I'm going to roll the dice and do a 5% chance that I crack a password. You can do that. And then you can try all the passwords you have. Let's say you got your hands on 100 different passwords. You can say 100 times 111. That's 1,100 days. Then you can take a 5% chance on those 100 passwords. And think about this kind of approach, which even involves a strategy. Well, it's still impractical, but there's a pretty good chance that you're going to hit a password within the 1,100 days. And that's roughly about 3 years. One more time. So we get back to the original 3 years of cracking. You're going to probably hit 1 or 2 or even more, because the mere chance or the randomness of you having a 5% roll with the dice. Let's assume you took a dice in your hand with 1,000 faces on it, and you rolled it 1,000 times. I'm pretty sure you will get something in between 1 to 5%. Anyways, this is the situation on Amazon Web Services. So yeah, let's assume. Just to give you an idea of which kind of password you would find this kind of list we talked about. These are the kind of password you can find. The one on the left side is just the ones you probably would say is more secure. And the one on the right side is probably one you would say is less secure. And that is correct, given into the consideration that we do use a hybrid approach, which basically means that we do use a specialized word list. If you're just going to create a password with 8 characters, well, use the left kind of way, but that is of course hard to remember. So you can also go ahead and use something called, RockYou, which is one I talked about before. It is a commonly used password list or word list containing more than 14 million previously leaked passwords. And if you use that list, different kind of instances we talked about could take down to around 3 seconds to, crack the password. If so, the password is in the list, meaning within the 14 million previously leaked passwords. And then it doesn't really matter if it's a password looking like the ones on the left side or the right side. If it's in the list, it is done within 3 seconds. And this is now we're gonna talk about why it is very important to pick a good password, because if you pick a password that is within the 14 million stupid ones, well, then you're going to be cracked. Basically, that's it. That is the way you're going to think about it. If you pick one that is, outside of it, and you can actually check that. I know that, the ordinary non-technical people will never think about these kind of things. They probably do not know about this RockYou password list. What is that, right? So I'm pretty sure that it's only people that involve themselves in some kind of penetration testing have this kind of knowledge. And this is why it's so important to understand that security is not just all about technical keyboard cranking, and no. It is actually about knowledge, Information security or cyber security, I would call it information security. Anyway, security is about the knowledge of what is actually possible, why is it possible, and then understanding the general, I would call it the algorithm in your head, in your mind. So you do fetch the general idea behind why is this a good idea or not a good idea. In this particular case, it's about passwords. So pick one that is not within the 14 millions, and you can easily do that by talking to your password, not your password officer. That sounds weird, right? Just one hired person to do passwords. No, just to talk with your IT security guys and like that. That's probably gonna help you a lot. So, conclusion-wise, I would say, even so, we talked about the amount of years it takes and so on to crack a password. Create one within 12 to 16 character range, and it is, even after the statistics we just saw, that is the approach. Why? Well, because specialized password lists will break most common passwords in seconds or minutes. And I'm just talking about one, the RockYou one, but I haven't talked about rainbow tables. I haven't talked about whatever kind of thing you can do. What you should think about is still go back to the numbers we talked about with the approach of a word list. Take that word list into consideration. It doesn't really matter if it's a rainbow table or not. It is also just a list of passwords, hashes with plain text. But it is the same kind of speed we're talking about, more or less. Don't overthink this too much. This is also, in a way, a rough estimate, but it's not that much off. So you could say, oh, it's very different in reality. No, it's not. This is reality, and this is what I want to say. So, I want to say thank you for watching this video with me, and I really hope that you learned something about it. This is the pro version of how you can hack passwords. Online, in the cloud, the cost of it. It is highly impractical, but very feasible. Are you going to do it? Are you going to pay for it? Are you going to try the free version from Amazon Web Services just to see what you can get from it? I'm going to create more free versions if you can do that in different accounts and combine them together. I don't know if that's possible, but you're probably going to give it a go someday if you want to try it. Let me know in the comment below what you think about this video. And don't forget, if you like the video, give it a thumbs up. Like the channel, even subscribe to see more interesting videos like this, hacking devices and so on in the future, to get the first notification in your channel. See you again online. Have a really nice day.